Hello, my name is Jess Stacy, and I'm the team lead of Team Olympus, and I'm here today with Clayton Klauser, Daniel Pachko, and Daniel Dorsey. And our group is tackling the private network cloud-based IoT system project. To introduce the project, I wanted to talk about the problem that we're trying to solve. And currently, with the systems that are being used on board NASA shuttles today, there's a big problem with having to deal with the size and weight and the heat and different aspects of what goes into the system that can really limit its power and its functionality. And we're hoping to expand upon that by creating a wireless private network IoT system that can be used to minimize weight, increase power, and increase adaptability. How we're going to solve this problem is by creating this private network cloud that is going to be able to use to communicate with edge devices and sensors located throughout the shuttle that can send their data and everything back to a centralized server for processing and handling. And then that can then send commands and everything back out to the edge devices. So to create this system, we've decided to go ahead and use ThingsBoard. It is a proprietary software that is available on the market today. It's open source and it works over a private cloud-based network. It runs on a variety of operating systems and has built-in protocols to handle telemetry and data collection. And it's scalable and works with Postgres SQL databases.
To fully use ThingsBoard, we're actually implementing it with two different applications. The first application is a smart entryway. Essentially what it is the setup of different sensors we have in this door-like structure where we detect whenever someone goes through it. In this model, we're basically doing it to where whenever someone sticks their arm through, we can tell if there's been a human that's gone through that door. Now, to do this, as you can see in our big diagram, we've used temperature sensors, an ultrasonic sensor, a touchscreen, a PIR sensor, a router, and the server computer. The main components of the door are all the ones going off of the Pi. Now, with the Pi itself, this Pi essentially takes all of this data and pushes it to the server. Now, the way that it does this is that we are connecting it with Mosquito protocol, also known as MQTT protocol. This is a TCP protocol that essentially allows us to have a full duplex of the information between the server computer and the Raspberry Pis. And this is specifically used for ThingsBoard. So with ThingsBoard, whenever we make the script for the Pis, for any of these applications, we just put it on there and we just sync up the token IDs and we have them both sync together. A device will appear on the main server on ThingsBoard and you'll start seeing telemetry. The main thing is you just have to make sure that you have a script in place on the Pi to get all that data and also to be able to get that data back to actuate to the certain things. In this case, it's our touchscreen. And by doing this, every time it detects somebody, it'll say a human is detected, or it'll shoot out a notification.
In application 2, we are using a vivarium to hold live plants and show that we can maintain an ecosystem using our IoT network. This is done with an array of sensors that monitor the humidity, lux value, and temperature of the environment. Our Raspberry Pi then sends its telemetry data to our server, where based on threshold values we set, a humidifier and heater will turn on to return our ecosystem to equilibrium. Through this, we believe that we have showed how our system can be used for life-critical functions on a remote shuttle or space station.
I also wanted to extend a special thanks to our professor, Dr. Robin, our lab technician, Alejandro, as well as our NAPA representative, Chatwin, and our TSGC contacts, Timothy Urban and Talia Jurgens. Just special thanks to all these guys. I know without a lot of the help they would have gotten along the way, this project definitely wouldn't have been possible. And so definitely just wanted to say thank you.